I am Mrs. K.Pushpanayaki, Associate Professor of Statistics, A.D.M. College for Women, Nagapattinam. Let us discuss about correlation. Introduction. Sometime it may happen that values of the variables so collected are interrelated. We may be interested to find if there is any relationship between the two variables under study. For example, the price of a commodity and its sales are related. With increase in the price of the product, the quantity sold is found to decrease, or if with a decrease in the price of the product, the quantity sold is found to increase. Therefore, we conclude that some relationship between the price and sale. Correlation is the statistical analysis which measures the closeness of the relationship between the variables. The word relationship is of importance and indicates that there is some connection between the variables under observation. Uses of correlation. Correlation is very useful to economists to study the relationship between the variables like price and quantity demanded. For businessmen, it helps to estimate cost, sales, price and other related variables. Number 2, correlation analysis helps in measuring the degree of relationship between the variables. Number 3, the relation between the variables can be verified and tested for significance with the help of the correlation analysis. The effect of correlation is to reduce the range of uncertainty of our prediction. Number 4, the coefficient of correlation is a relative measure and we can compare the relationship between the variables. Next, the types of correlation. Number 1, positive correlation and negative correlation. This is based on the direction of the movements of the related variables. Number 2, simple, multiple and partial correlation. This is based on the number of variables which we are taking for our study. Number 3, linear and non-linear correlation. This is based on the ratio of changes between the variables. Let us discuss one by one. Positive correlation. When the values of two variables change in the same direction, there is positive correlation between the two variables. That means both the variables are moving. Suppose first variable is increasing, the related another variable is also increasing. The first variable is decreasing, the related another variable also decreasing. That is called positive correlation. That means both the variables are moving in the same direction. For example, height, weight, rainfall, yield of crops, price and supply. Next, negative correlation. When the values of two variables change in the opposite direction, that means first variable increases, the related another variable is decreases. The first variable is decreasing, the related another variable is increasing. That is called negative correlation. The example, price and demand. Next is simple correlation. In simple correlation, we take only two variables. The relationship is described as simple. For example, demand and price or price and supply, etc. Multiple correlation. When we study more than two variables simultaneously, the relationship is described as multiple correlation. For example, relationship between price, demand and supply of a commodity. This is an example for multiple correlation. Next, partial correlation. When more than two variables are considered, the correlation between two of them when all other variables are held constant. That means we are assuming that there is no change, is called partial correlation. For example, when we study price and demand eliminating the change in the supply side, that is called partial correlation. Next, linear correlation. The ratio of change between two variables is uniform. Then there will be linear correlation between them. Consider the following example. So, x and y are related variables. X takes the value 5, 10, 15, 20. Another related variable y, 4, 8, 12, 16. The ratio of change between the two variables is same. If we plot these points on the graph sheet, we get a straight line. That is called linear correlation. Next, non-linear correlation. In curvilinear or non-linear correlation, the amount of change in one variable does not bear the constant ratio of amount of change in the other variable. Next, let us see what are the methods available for studying the relationship between the variables. Number 1, scatter diagram. Number 2, Pearson correlation coefficient method. Number 3, Spearman's rank correlation method. Number 4, concurrent deviation method. Okay, let us discuss one by one. First one is scatter diagram. Let xi and yi, that is x and y are related variable. It takes n values, I ranges from 1 to etc. n, be the pair of values of two variables x and y. A point is plotted on a graph sheet corresponding to each pair of the values. The resulting diagram with n point is called scatter diagram. The possible type of scatter diagram and the symbol linear correlation are given below. The first figure, perfect positive correlation. In this, the values are, both the values are moving in the same direction. We plot these points on the graph sheet. It is going on increasing direction. Okay, that is called perfect positive correlation. Next one is perfect negative correlation. In this, both the variables are moving in the opposite direction. When we plot all these points in the graph sheet, we will get the points are falling down in a straight line. That is called perfect negative correlation. Next, degree of correlation for some other, that is, it is moving from the straight line. The points are moving from the straight line. First one is strong positive correlation, that is increasing direction. Next one is decreasing direction, that is strong negative correlation. Still the points are scattered more, that is called weak positive correlation. Next, moderately negative correlation. Then we cannot decide which direction the variables are moving, that is called no correlation. Next, the points are scattered away from straight line, that is called weak negative correlation. Merits of scatter diagram method. Number 1, it is easy to draw. It is non-mathematical method, that is calculation is not necessary. Number 3, it is simple to understand. Number 4, this does not involve computation. Demerits of scatter diagram. It gives only a rough idea. We cannot determine what amount of relationship exists between the variables. Number 2, comparison is not possible. Next method. Number 2, Pearson coefficient of correlation. This is a mathematical method. It is the most widely used method in practice, is known as Pearsonian coefficient of correlation. It is denoted by the small letter r, which is defined as covariance of xy divided by standard deviation sigma x sigma y. We can represent also r equal to summation xy divided by n into sigma x sigma y, where small x represent x minus x bar, small y represent y minus y bar. Where the formula for covariance of xy equal to summation x minus x bar into y minus y bar, the whole divided by capital N. The formula for sigma x, that is sigma x is nothing but standard deviation of x, that is root of summation x minus x bar whole square divided by n, and standard deviation of y, or we can say sigma y, that equal to root of summation y minus y bar whole square divided by capital N. Then when you expand the square and after taking the root all these things, we get the final formula. For calculation purpose, most of the time we are using this formula, that is correlation coefficient r equal to n into summation xy minus summation x into summation y, the whole divided by root of n into summation x squared minus summation x whole squared into n into summation y square minus summation y whole square. The range for correlation coefficient always lies between -1 to +1. Interpretation of coefficient of correlation. When r equal to +1, then there is a perfect positive correlation between the variables. When r equal to -1, then there is a perfect negative correlation between the variables. When r equal to 0, then there is no linear relationship between the variables. Properties of correlation coefficient, or we can say that characteristics of correlation coefficient. Number 1, the correlation coefficient always lies between -1 to 1. It can be also denoted by in terms of symbol -1 less than or equal to or less than or equal to +1. Number 2, the correlation coefficient is independent of change of origin and scale. Number 3, the coefficient of correlation is the geometric mean of two regression coefficients. Merits and demerits of Pearson correlation coefficient method. Merits. Pearson method is the most popular mathematical method. Number 2, the coefficient of correlation summarized in one figure the degree of relationship and also the direction of the relationship. Demerits, assumption of linear relationship between the variable is not verified whether it is correct or not. Number 2, the calculation of coefficient of correlation is time consuming. Then next, probable error. The probable error is nothing but coefficient of correlation. Probable error of coefficient of correlation is defined as 0.6745 into 1 minus r square divided by root n. If the value of r is more than 6 times the probable error, the value of r is significant. Next, the problem part. We are taking only two variables, that is simple linear correlation. Then x takes the value 100, 110, 120, 105, 125, 130, and y takes the value 90, 85, 80, 75, 72, 70. We are using this formula, Pearson coefficient of correlation R equal to summation x minus x bar into y minus y bar whole divided by root of summation x minus x bar whole squared into y minus summation y minus y bar whole square. Then we are writing the x value. After summing up the x value, that is called summation x, that equal to 690. To find the mean, we use the formula summation x by n. N is nothing but number of pairs of values given. So find the mean value first of all for x. After finding the mean value, we have to take the deviation of x from deviation of each x value from mean. So we getting the mean value. As we found the mean value, we take the deviation. So we are taking the deviation x minus x bar. So minus 15, minus 5, minus plus 5, minus 10, plus 10, 15. After that, we have to square this deviation. That is 225, 25, 25, 100, 100, 225. We summing up this part. This part is necessary to find the standard deviation of x. Next, similarly we have to the calculation for y also. First of all, find y bar value. After finding y bar, we have to take the deviation of each y to y bar. So we got it as 11.33, 6.33, 1.33, 3.67, 6.67, 8.67. So next, y minus y bar whole square, that is we have to square the deviation values. In this we got it as 128.37, 40.07, 1.77, 13.47, 44.49, 75.17. So the summation of y minus y bar whole squared equal to 303.34. This is necessary for finding standard deviation of y. Next, we have to find x minus x bar into y minus y bar. That we got it as minus 169.95, minus 31.65, 6.65, 36.7, minus 66.7, 1 minus 130.05. When we are summing up summation y minus x bar into y minus y bar, we got it as minus 355. X series, mean of x. So x bar equal to summation x by 1. N 690 divided by 6, we got it as 150. Then squaring of summation x minus x bar whole squared from the table, we got it as 700. Then y series, mean of y bar equal to summation y by n, that is 472 divided by 6, that equal to 78.67. Summation y minus y bar whole square, we got it as 303. So summation x minus x bar into y minus y bar, we got it as minus 355. We have to substitute all these values in the formula. Summation x minus x bar into y minus y bar whole divided by summation x minus x bar whole squared into summation y minus y bar whole square, which equal to minus 355 divided by root of 700 into 303.34. So we have to multiply the denominator part within the root. So after taking the root, we got it as 460.80 in the denominator. Numerator, as it is minus 355. After dividing, we got it as minus 0.7703. For two decimal correction, we take it as minus 0.77. The correlation coefficient R equal to minus 0.77. Hence, we can say that the relationship between the two variables is negative. Next problem, we will see the next model problem. So calculate Pearson coefficient of correlation from the following data. X takes the value 10, 12, 14, 16, 17. Y takes the value 5, 6, 8, 9, 10. We using direct formula, that is R equal to n into summation xy minus summation x into summation y, the whole divided by root of n into summation x squared minus summation x whole squared n into summation y squared minus summation y whole square. In this part, it is not necessary to find mean value. As it is keeping of x and y, we can do this calculation. You see the columns. First of all, you have to write x and y column values, then square the x value, after that square the y value, next xy. Okay, we have to sum up all the column totals. For summation x, we got it as 69, summation y 38, summation x squared 985, summation y squared 306, summation xy, we got it as 548. N equal to nothing but number of value which are given, that is 5. Now we are substituting all these values in the formula. After simplification, we got it as 118 in the numerator, the denominator 164 into 86, that is. After that, we have to multiply in the denominator within the root value, that got it as 14,104. Next, so after taking the root in the denominator, we got it as 118.76. The numerator, we are having 118. So after dividing, we got it as 0.9936. So we can say that x and y are highly positively correlated. In this, we have x takes the value x, we are taking that height of fathers, and y we are taking that height of sons. Then we are using the formula Pearson coefficient of correlation R equal to n into summation dx dy minus summation dx into summation dy, the whole divided by n into summation dx square minus summation dx whole square into n into summation dy square minus summation dy whole square. We are using assumed mean method. That is, we are taking one value as assumed mean. In x part, assumed mean of x equal to 67. In y part, assumed mean of y equal to 68. Based on which we are taking the deviation of x from each value of x, and similarly for y. In that, first you write the height of father, that we are taking it as x. So deviation from assumed mean 67. So we have to subtract 67 from each value of x. We got it as -2, -1, 0, 0, 1, 2, 4, 8, 6. When we are summing up this column, we got it as summation dx equal to 10. Next, square this deviation value, that 4, 1, 0, 0, 1, 4, 16, 36. When you are summing up some d squared, we got it as 62. Next, we are taking height of son as y. Then after that, next column we are opening that dy, that is nothing but we have to subtract 68 from each y value. We got it as -1, 0, -4, 0, 4, 2, 1, 2. When you are summing up this column, summation dy equal to 4. Next, we have to square this deviation value, that is denoted as dy square. That is 1, 0, 16, 0, 16, 4, 1, 4. When you are summing up, summation dy squared equal to 42. Next column, dx dy, that is product of deviation of x and y series. So when we have got this column, the values are 2, 0, 0, 0, 4, 4, 4, 12. When summing up, summation dx dy equal to 26. Next, we have to substitute all these total values in the formula. So formula we have to write once again, R equal to n into summation dx dy minus summation dx into summation dy, the whole divided by n into summation dx square minus dx whole square into n into summation dy square minus summation dy whole square. Summation dx dy from the table 26, summation dx equal to 10, summation dy equal to 4, summation dx square equal to 62, summation dy square equal to 42, number of value n equal to 8. We are substituting all this value in the formula and simplified. Finally, we got it as 0.478. So based on this answer, we say that the variables x and y are, that is heights of fathers and sons, are positively correlated. Next, we are going for third method, Spearman's rank correlation coefficient. Spearman rank correlation coefficient, rho is defined. We are using the symbol rho, that is it is defined as 1 minus 6 into summation d squared divided by n into n squared minus 1, where d is difference between the ranks of two variables. Rank correlation coefficient also lies between -1 to +1. When the values are repeated, the rank correlation coefficient is calculated based on the following formula, rho equal to 1 minus 6 into summation d squared plus correction factor. CF means correction factor. divided by n into n squared minus 1. The formula for correction factor CF equal to m into m squared minus 1 plus 12 plus etc. Where m is the number of times the value is repeated, CF represents correction factor. The merits and demerits of rank correlation coefficient method. Merits, it is simple to understand and easy to calculate. It is very useful in the case of data which are of qualitative nature like intelligence, honesty, beauty, efficiency, etc. No other method can be used when the ranks are given except this. When the actual data are given, this method can also be applied. Demerits, it cannot be used in the case of bivariate distribution. If the number of items are greater than say 30, the calculation becomes tedious and requires lot of time. Case 1, when ranks are given. Problem number 1, find Spearman's rank correlation coefficient from the following data. Ranks of X 1, 3, 2, 4, 5, 6, 8, 9, 17. Rank of Y 4, 2, 5, 7, 8, 9, 10, 3, 1, 6. The formula for calculating Spearman's rank correlation coefficient rho equal to 1 minus 6 into summation d square divided by n into n squared minus 1, where d equal to r1 minus r2. N represent number of pairs of observation, R1 represent rank of X, R2 represent rank of Y. Now we are opening the column R1, the given first column value as taken as R1, next R2, next we take the deviation between R1 minus R2, after that the deviations are squaring. We need a summation d squared, that we got it as 138, now we are substituting this value in the formula, rho equal to 1 minus 6 into summation d squared divided by n into n squared minus 1, 1 minus 6 into the summation d squared value is 138, then n equal to 10, so 10 into 10 squared minus 1. After simplification we got it as 0.164, then we say that next the result, hence the low positive, because the low positive correlation between the variable x and y, the reason is that the value is 0.1, therefore we are saying that low positive correlation. When the ranks are not given, previous problem ranks are given in the problem itself, here the actual values are given. First of all we have to assign the rank for these actual values, after that as usual procedure. The Spearman rank correlation coefficient, the formula is 1 minus 6 into summation d squared divided by n into n squared minus 1, where d equal to r1 minus r2. R1 represent the rank of X, R2 represent rank of Y, then n represent number of pairs of observation. Next we do the calculation part, and here we write X and Y value. The given values are written. After that R1 means rank of X, we represent the rank for the given values. So that is 69 carries first place, 60 carries second, and 56 third, 55 fourth, fifth rank, 46 sixth rank, 45 seventh rank, and 34 8th rank, 32 9th rank. Next R2, 70 carries first, 67 second, then 65 third, 62 4, 65, then 58 6, 52 7, 58 and 14 9th rank. Okay, next we have to take the deviation between these two rank. So after that we square the deviation values. Finally we got summation d squared equal to 90. We have to substitute these values in the formula. Finally we got it as 0.25. Then the result, rank correlation coefficient is 0.25, hence there is positive correlation between X and Y. Next part, the ranks of 10 students in two subject A and B are given as follows. Calculate rank correlation coefficient. Rank correlation coefficient rho equal to 1 minus 6 into summation d square divided by n into n squared minus 1. So this type of problem previously we have seen. Next, in this you see that the competitors in a beauty contest are ranked by 3 judges in the following order. First is given the ranks for the 10 competitors. Second judge given the ranks for the 10 competitors. Third column represents third judge given the rank for the 10 competitors. Use the rank correlation coefficient to determine which pair of judges has the nearest approach to common taste in beauty. For this, we have to take a pair of values. That is, first we consider first and second judge. Second, we take the second and third judge. And third, we take the first and third judge. We have to calculate 3 rank correlation coefficient and compare the result. If the result is high, the positive, the result, that is, the value must be positive. If the value is higher than the other two, then we can say that that pair of judges has the nearest taste in common taste in beauty. Okay, let us see the calculation. R1, that is the first judge rank, we denote it as R1. For the second judge, rank values are denoted as R2. Third judge, rank values are denoted as R3. First of all, we take the first and second. The difference of first and second, we denote it as D1. So next, second and third pair, we are taking it, that is denoted as D2. Next, R1 and R3, that means first and third judge, we are taking that is denoted as D3. We have found the difference. After that, square the differences. Finally, we use these total values in the formula. Rank correlation coefficient between first and second judge, R1 or 1 minus 6 into summation D squared and N squared minus 1. From the table, we got it, summation D1 square equal to 200 and equal to 10. We substituting this in the formula. So 1 minus 6 into 200 divided by 10 into 10 squared minus 10. That equal to 1 minus 120, 990. 1 minus 1.212, that equal to minus 0.212. Okay. For the next calculation, in this, the rank correlation coefficient between judges second and third. For this one, summation D2 square, we got it as 214 and equal to 100. Substituting in the formula, we got it as the answer is minus 0.297. Next, third pair of judges, we take first and third. In this, summation D3 square equal to 60 and equal to 100. We substituting all these values in the formula. After simplification, we got it as 0.636. Result, for the rank correlation coefficient for first and second judge, minus 0.212. Rank correlation coefficient for second and third judge, that we got it as minus 0.297. The rank correlation coefficient for first and third judge, we got it as plus 0.636. Comparing these three values, we say that first and third judges has a positive value, so that got it as 0.636. Therefore, we say that first and third judges has common taste in beauty. Here, when the values are repeated or equal ranks, so compute the Spearman's rank correlation for the following observation. We are having 8 candidates. Judge X given the marks 20, 22, 38, 23, 30, 30, 23, 24. The Judge Y given the marks for those students 28, 24, 24, 25, 26, 27, 32, 30. Marks are awarded out of 35. Okay. Solution. The Spearman rank correlation coefficient, we are having the formula rho equal to 1 minus 6 into summation D squared plus correction factor divided by n into n squared minus 1. Correction factor is nothing but m into m squared minus 1 divided by 12 plus m into m squared minus 1 divided by plus 12 plus etc. This the m term has to be added. How many values are repeated? So 8 candidates are given. You write the candidate numbers. Next, judge the marks of the judges. Here you see that marks of the judge 20, 22, 28 and 23 is repeated. 23, 30, 30, 23, 24. Okay, next R1, we are giving R1, 2. That is the lowest number. We are giving the rank 1. Next number 2. Then 23 is repeated 2 times. We assign actual ranks 3 and 4 and take the average of these 2 ranks. We got 3 plus 4 equal to 7. 7 by 2, we got it as 3.5. That has to be assigned for those values. 23. 3.5. So once again, the corresponding to another 23, 3.5. Next value, we have to assign the rank 5. That is 24 carries the rank number 5. Next 28, 6. Next 30 also repeated 2 times. So we have to assign 7 and 8. It take the average for 7 and 8. 7 plus 8, 15 divided by 2. We got it as average rank as 7.5. This has to be given for those 30. Next Y. 28, 24, 24, 25, 26, 27, 32, 30. Here the 24 is repeated 2 times. For the 24, first 24 carries rank number 1, second 24 carries rank number 2. We have to take the average for these two. 1 plus 2, 3, 3 by 2 equal to 1.5. That number has to be given for these 24. That is 1.5, 1.5. For the another value, we have to assign the rank number 3. Next, 26 carries rank number 4, 27 carries 5, then 28 carries 6, 30 carries 7, 32, 8. Okay. Next, as usual, we have to take the deviation between R1 and minus R2. After that, we have to square the deviation values and sum up that column. We got it as 88.50. So, we have to calculate correction factor. Here, we are having 3 values are repeated. In X column, 2 values are repeated. In Y column, 1 value is repeated. M is nothing but number of times the value is repeated. For the first repeated value, we have to add one term, that is M takes the value 2. M is nothing but number of repetition. That first repeated value repeated 2 times, therefore M equal to 2. 2 into 2 square minus 1 divided by 12 plus another repeated value, that is 30. That is also repeated 2 times, therefore M equal to 2. That is 2 into 2 square minus 1 divided by 12. In Y column also one value is repeated 2 times. Therefore, 2 into 2 square minus 1 divided by 12. After simplification, we got it as 1.5. We have to substitute all these values in the formula. Rho equal to 1 minus 6 into summation d squared plus cf divided by n into n squared minus 1. Summation d squared from the table, we got it as 88.5. For the correction factor, we got it as 1.5. We have to sum up these 2 values, that gives us 90. This has to be multiplied with 6. That we got it as 540. In the denominator, after simplification, we got 504. Then after simplification, finally we got it as minus 0.07. The rank correlation coefficient is minus 0.7. Hence, there is low negative correlation between the variables. This is another model, same type of problem, another model, the same type of calculation. Thank you.